Alright, the last problem says, well, it asks us to find the average of all the counting numbers less than 100 that are multiples of 3. So, let's see. I have a hint for you, but first of all, let me just write out here what we're asked to do. We're asked to add the numbers. So the first counting number that's a multiple of 3 is going to be 3. And then we'd have 6, and then we'd have 9, and then we'd have 12, and 15, and so on. Okay? And the last number in this list would be 99, the last multiple of 3 that's less than 100. Okay? So we're asked to find the average of all these numbers. So to find the average, we add up for any set of numbers that we want to find an average of, we add them up and divide by the number of numbers. So here we need to essentially add these numbers up and then divide by the number of numbers. But that looks like kind of a lot of work to add all those numbers up. I mean, you could do it. You could sit there and add them and add them and add them and add them. But there's a trick to adding numbers that are evenly spaced. So you can see these are all evenly spaced by 3, right? The numbers are all evenly spaced by 3. So there's a little bit of a trick. And for a hint to this problem, I want to tell you a little story about Carl Friedrich Gauss. You can look him up on the internet and learn more about him. Friedrich Gauss. Okay. He was a mathematician, lived back in the 1800s, and there's a story about him that when he was a young boy in school, his teacher was tired one day and wanted to keep the kids busy so he could rest. So what he did is he told the kids to add up all the numbers from 1 to 100. Okay, and I'm going to say dot, 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 dot. And we'll say 99 and 100. Okay? So he told them to add all those numbers up. So, most kids would say, okay, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and then they just keep adding, adding, adding. But Carl Friedrich Gauss looked at this list, and as a true mathematician, he wanted to do it he wanted to add this thing efficiently. He didn't want to spend a lot of time just doing a bunch of number crunching. So he looked at it and thought about it and came up to the teacher within a few minutes with the answer. So the question is, how did he do it? Well, what he noticed was that if you take the last number and you add it to the first number, you get 101. So let me just draw. Okay, so that's 101 if you add those up. If you take the second number and add it to the second to the last number, you also get 101. The third number, and the third to the last number wouldn't be 98, of course, so 3 plus 98 would also be 101. And so essentially you'll have 50 pairs. You got 100 numbers, so you'll have 50 pairs of 101. So all he did was take 101 times 50 and got 50, 50. Okay? You see how he did that? Neat trick, I tell ya. Very neat trick. But that's not the answer to our question, of course. But that's my long my long hint to you, is that you may be able to find a similar pattern that Gauss did for this set of numbers. Okay? So that's my hint to you. See if you can use that information to solve this problem where we have to add up all of the multiples of 3 from 3 up to 99. And don't forget, too, that we're taking the average, so we have to divide by the number of numbers as well. So there's my hint. Okay? So, and here is the solution. Let me see. I'll just scroll down here and make us some more room. Alright. So let's take a look at this list of numbers. I'm going to actually define some variables just to, let's say that S is equal to the sum. Actually, let's do this. Instead of the sum, I'm going to say, let's just say that it's equal to 3 plus 6 plus 9 plus 12 plus dot 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 all the way up to 99. Okay, let's just call that S. And let's also define a variable n, which is the number of numbers in this list. Okay, so if we want to find the average is just equal to the sum over the number of numbers. Alright, so what I'm going to do, let's look at this list and try to use do something similar to what Gauss did. Alright, so let's take a look at 99 plus 3. So 99 plus 3 is what? It's 102. Okay, and the number before 99 would be 98, right? So if we were to take 6 plus 98, oops, sorry, it won't be 98, will it? It'll be a multiple of 3, which is 96. Alright? If you add those up, you get 102. Alright? The number before that will be 93. Right? And if you add 9 and 93, you get 102. Okay. So, we do have a similar pattern. It's not quite the same. It's not a list of counting numbers like Gauss had. It's a list of multiples of 3. But this technique actually works for any arithmetic sequence. And an arithmetic sequence is one in which the difference between consecutive numbers is a constant. So you can see we have the gap between numbers is 3 every time. So every number in the list is the first number plus a multiple of 3. Okay? So, and let's actually do this a little bit differently from what Gauss did. Let's actually write this list backwards. If we write this list backwards, plus dot 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 plus, let's say 9 plus 6 plus 3. This is still equal to the sum, right? It's just the same thing, only it's written in a different order, right? But if we do it that way, we can actually add these numbers up, and we'll get 102 plus 102 plus 102 plus dot 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 plus 102 plus 102 plus 102, right? So we'll essentially have 102 times the number of numbers, and this will be equal to, now we've added up this sum twice, so now we have 2s. Okay? So 2s will be the number of numbers divided by the number of numbers times 102. Okay, so 2s is the number of numbers times 102. Okay, so So then S will be 102. Now I'm just going to use, actually we defined over here the number of numbers. So I'm going to say 102 times n over 2 is the sum. Okay? And we can divide 102 by 2 and we get 51 n. Alright? And then we know that the average is equal to S. So I'm going to write that down. Average is equal to S over n, right? The sum over n. And that S is just 51n. So I'm just going to write that as 51, whoops, not 15. 51 n over n. Now n over n, that's just 1, so we can just cancel that out, and the average is 51. Pretty neat trick, huh? Gauss was a pretty ingenious guy. I don't know, if that would be pretty tough to figure that out on your own. That would make you ingenious. So so we can learn from Gauss, and we can apply his tricks and to add up numbers that are arithmetic. Okay, and really any set of numbers that are arithmetic, you can take to find the sum. You can take the first number. You can take the first number. I'm just going to write it out this way. First number plus the last number, and take it times the number of numbers and divide it by 2. Okay, it works for any arithmetic sequence, and an arithmetic sequence is one in which the space between the numbers is constant. Okay, or you could think of it as every consecutive number is the first number plus a multiple of some number. Okay, so this is a very handy little thing to know. Okay, so be looking for more problems that will use that.